We are continuing with solving our multi-step problems, and with each day we will beef it up a little bit, throw in a little curveball, and let's see what today brings us. So the first thing that we are going to do, we've got these steps. We are going to either, one, with these problems, apply the distributive property, or we are going to divide. We will pick and choose. Next, we're going to combine like terms on both the left and the right side of the equation so that we can simplify. And third, we are going to isolate that variable, and we're going to do that by using our inverse operations. So let's start with our first example. So folks, we're going to try this example, and just a heads up, we are going to do this two different ways. Let's start with way one. We're going to use green, which is the distributive property. So let's knock this out. So for the first step, I notice that I do have a number that's being multiplied to what's in the parentheses. So I am here going to distribute that 3 to both terms. 3 times 3y is 9y, and 3 times minus 4 is minus 12. And then I just bring down the 33. All right, so we've checked off number one. Number two, combine like terms on each side of the equation. You'll notice there aren't any like terms on either side, so I'm moving on to 3. I'm isolating the variable. So here I'm going to get the y by itself by adding 12 to both sides. So that simplifies the left side to just 9y. And then the right side, we take the sum of 33, 12, and we get 45. I still want y by itself. So our next operation, 9 is being multiplied, so I do the inverse operation. We divide both sides by 9 to get y alone. So that leaves us with y on the left side, and 45 divided by 9 gives us 5. Now let's look at this problem through a different lens. I'm going to look at this example, and I notice that 3 is being multiplied to this whole quantity, 3y minus 4, and that's all that we have on that side of the equation. If that's the case, then I might divide both the left and the right side by 3. And you'll notice if I do that, 3 divided by 3, that goes away, and that's nice, leaves me just with 3y minus 4. And then 33 divided by 3 leaves us with 11. So now I'm on to step 2, combining any like terms. There aren't any, so I'm checking off 1 and 2, and I'm going on to 3. I'm isolating that y. So now I'm going to move the 4 over by the additive inverse. So that leaves us with 3y, and 11 and 4 gives us 15. And now we divide both sides by 3, and we still get that y is equal to 5. Now let's look at example 2 here. And again, we have the option of either distributing or dividing. And I am taking note of the division part because the entire side, the entire left side of the equation is being multiplied by 3/4. So in this case, I could either distribute, which would be a little bit messy, or I could get rid of this fraction by some other operation. So how can I get rid of 3/4? Well, I could divide both sides by 3/4. What is the same thing as dividing by a fraction? Multiplying by its reciprocal. So let's take that approach for this problem. So I'm going to multiply both the left and the right side of the equation by the reciprocal of 3/4. So then 4 and 4 and 3, those cancel out, and that leaves us with a nice clean 2x minus 6 on the left side. Now you'll notice here, if I put the 9 over 1, I can simplify this, or I can have Desmos work this out for me. 3 times 4. I get 12 if I multiply 9 over 1 by 4 over 3. It simplifies to 12. So now we have this equation, 2x minus 6 equals 12. We add 6 to both sides. That's our additive inverse. We want to get rid of that 6. Leaves us with just 2x on the left side. We take the sum of 12 and 6, and we get 18. I want x alone. It's being multiplied by 2. So I divide both sides by 2. Those cancel out, and that leaves us with x equals 9. Now let's look at this last example. One thing I want you to be mindful of for example 3 is we notice here with the 4 and the 2x minus 1 that 4 is only multiplied to the 2x minus 1, and then I've got the rest of this, these two terms on the left side. So here I do not want to divide because the entire side is not being multiplied by 4. So in this instance, all I want to do is apply my distributive property. So let's do this. So for example 3, we are going to distribute the 4 to both terms inside the parentheses. So that's 4 times 2x, 8x. We multiply 4 to minus 1, and we end up with minus 4, and everything down we're just collecting equals negative 8. Lovely. So now we finished with step 1. Now we're on to step 2. Let's combine like terms on both sides of our equation. So if we're seeing, I've got an 8x and a 3x. Those are my like terms. And then I have minus 4 and minus 15. Those are like terms too. So let's work with the green first. I've got 8x, and I'm adding 3x to it. That's a total of 11 x's. And so now I'm moving on to the constants. I've got minus 4 and minus 15. So I've got a minus 4, minus 15. That combines to negative 19. So I have 11x minus 19 equals negative 8. I want to isolate that x. What's my next step? Let's get rid of that minus 19. How? We add 19 to both sides. So we're left with 11x, and negative 8 plus 19 gives us 11. So I have 11x equals 11. I want x by itself. It's being multiplied by 11, so we divide both sides by 11. And we're left with x equals 1.